In a previous video, we walked through the core principles of sampling. Today, we're taking it a step further with Datadog's smarter capabilities. If the default setup doesn't give you enough control and you want to stay on top of your budget, this video is for you. Now that we've mastered sampling behavior and retention, there's one final challenge: balancing visibility with cost. That's where adaptive sampling comes in. Your autopilot for ingesting exactly what matters without the shock of an unexpected bill. Let's start with the basics: what adaptive sampling is and the problem it solves. It allows you to set a monthly ingestion target for one or more services. Datadog then automatically adjusts the sampling rate to balance visibility with cost. It also ensures that low-traffic endpoints aren't forgotten by guaranteeing at least one trace per service, resource, and environment every 5 minutes. If your ingestion bill is climbing, this feature will interest you. So how do you get started? Before switching on autopilot, make sure a few things are in place. Datadog Agent version 7, 53.0 or higher, since adaptive sampling relies on new agent features. Remote configuration enabled, with APM remote configuration write permissions. And finally, tracing libraries that meet the minimum version requirements. Check the documentation for the exact details. So how do you configure adaptive sampling? First, head over to APM and open ingestion control. Here, you'll see all the services currently being reported. Since I don't have much traffic right now, I'll expand the view to 2 weeks. From here, I can see all my services. And the first step is to select which ones I want adaptive sampling to monitor. When I click on a service, I can see all the reported endpoints along with details like origin and metadata. Since I want to control the specific service, I head to Manage Ingestion Rate. Instead of sticking with custom sampling, I select Datadog Adaptive Sampling, hit Apply, and the configuration is instantly updated. Let's apply it now. Now you can see adaptive sampling is enabled and active for this service. Let's close it out and move up a level to manage ingestion for all services. From here, we'll configure adaptive sampling across the entire setup. Here I've got 2 options. The recommended one lets you define ingestion volumes per host. Remember, every APM host includes 150 gigabytes by default, and on top of that, you can also set a global budget for the entire month. I recommend using this option too. You can set it at 100% to make sure you never exceed your included volume, or raise it slightly if you want extra visibility across your setup. Ultimately, it comes down to your budget and priorities. Just below, you'll notice it's currently targeting a single service. Here, Datadog provides a quick analysis so you can see exactly what that configuration means in practice. If we dive into the details of this formula, we can see my global allotment, calculated from all the hosts and serverless functions I currently run. This is the target I just configured. Looking across the services under adaptive sampling, my current share comes out to 5.8%. You can also choose a lower rate. This number represents the maximum expected volume by the end of the month. All that's left is to apply the monthly targets and you're set. Before moving on, let me quickly show you another example from the documentation. In this case, we set a higher budget for an APM host, covering 144 hosts and 125,000 function invocations. Based on the configuration, you can see the total allowance here, along with the current target set for services under adaptive sampling. Because only a few services are using it, the relative percentage shows at 1.19%. The resulting monthly target is quite low, meaning the impact on the overall bill is minimal, but it's still a good starting point. If you prefer budgeting by total volumes instead of per APM host, the setup looks very similar. You'll review each service, see how much it's currently ingesting or contributing, and then assign monthly targets directly at that level. The final step is to return to the service and confirm the configuration changes. For now, mine still shows as automatic, but it will update shortly. As noted in the documentation, once everything is properly set up, the configuration shifts from automatic to adaptive remote. These updates apply once the agents and tracing libraries pick them up. Depending on your setup, you may briefly see other configurations until everything syncs. At this point, it's just a matter of waiting for all endpoints in my example to finish updating. And that's adaptive sampling. Configure it once, and Datadog automatically steers your trace ingestion toward your monthly target, while still capturing low traffic paths. It's smart budget-aware observability on autopilot. We've now covered head-based sampling and ingestion level controls, so let's go one layer deeper. What if you only realize a trace is important after it finishes? That's where tail-based sampling comes in, ensuring you don't miss critical high-impact events. So what is tail-based sampling, and why does it matter? Unlike head-based sampling, it makes the keep or drop decision after the trace completes, meaning you have the full context, like error codes, latency, or span attributes, before deciding whether to retain it. Here are a few use cases. Always capture traces with errors. As we saw in part 1, errors aren't known at the start, so you need the complete trace to decide. Capture high latency traces, since latency is only known at the end. Or filter by downstream attributes, like keeping all traces from tier 0 customers. That data only becomes available once authentication completes. So how do you implement it? Let's start with a full Datadog setup. The simplest option is to send everything to Datadog, possibly with hard-coded sampling rules per service. This guarantees full visibility but will raise your ingestion bill. With complete traces in place, you can then decide which ones to retain for 15 days. For very large enterprise apps with heavy traffic, this approach often isn't viable. The ingestion cost may be under 10 cents per GB, but at scale, that adds up quickly. For those cases, even ingesting just 20% or less can still provide statistically meaningful visibility. It's not full tail-based sampling, but it offers a practical balance. Another option is to use the OpenTelemetry collector with the Datadog exporter. In this setup, your applications send traces to an OTel collector, which applies tail-based sampling logic via the tail sampling processor, and then forwards the sampled traces to Datadog. The tail sampling processor supports multiple policies, like always_sample, latency, status_code, probabilistic, attribute-based, and even composite rules for precise control. The catch is that all spans from a trace must land on the same collector instance to ensure correct decisions. While this doesn't add to Datadog costs, it can create significant infrastructure overhead to handle large volumes of trace data. Before adopting tail-based sampling fully, consider the trade-offs. With Datadog, all spans must be ingested, which can raise costs for certain apps. With OTel, tail sampling requires buffering spans until a trace completes, increasing memory and compute usage. In both cases, trace completeness is critical. Tail sampling only works if all spans reach the same collector or Datadog backend. If spans are split across instances, decisions may be incomplete. OTel also introduces operational complexity. Managing tail sampling rules in the collector adds another layer to your observability stack, something only teams with very specific precision needs should take on. In short, if your main concern is catching problematic traces, like errors or latency spikes, tail sampling gives you the highest precision. Just be prepared for the added cost and complexity. For most teams, the earlier methods we explored already provide strong statistical visibility, even at scale. So while tail sampling may look like the silver bullet, it's not always cost efficient, and the extra observability gain may not justify the expense. Of course, the picture wouldn't be complete without mentioning OTel sampling. In this section, we'll quickly walk through how to set it up. So how does it work in practice? Depending on your OTel setup, you have two options. The first is to use the OTel collector with the Datadog exporter. In this case, you'll likely rely on probabilistic sampling, or the tail-based sampling approach we covered earlier. The second option is simpler. Use Datadog agent OTLP ingestion. Here, your OTel instrumented apps send traces directly to the Datadog agent over OTLP. The agent applies probabilistic sampling, which you can configure either through the shown config or environment variables. This approach is ideal for straightforward setups, where you want basic sampling control without deploying a separate collector. And there you have it, your foundational stack for precise cost-conscious observability. Begin with agent-managed head-based sampling. Add overrides for your priority paths. Always capture errors and rare signals. Index the traces you need long-term. Automate ingestion with adaptive sampling. And use tail sampling when end-of-trace detail really matters. That's the complete picture of sampling. Now it's your turn. Review your trace strategy, tweak a knob or two, and see the difference. If you are still interested in how it looks in the UI, stay tuned for part 3 of APM sampling. Let me know what you discover. Happy monitoring, and remember, smart sampling means clear visibility without the bill shock. For more best practices, hit subscribe. And as always, happy monitoring.